rates of change and some behaviors of graphs that we want to consider. So we have this chart about gas prices between 2005 and 2012. So the y value is the year, and then the function c of y gives the output for the cost of a gallon of gas. So the questions are, how has the price of a gallon of gas changed over these 7 years? Well, if we watch it, it looks like it's gone up here by about 31 cents, and then up 22 cents, and then a big jump. And then between 2008 and 2009, it decreases and then increases again. But these increases aren't uniform. And so what we want to know is, to answer this first question, how's the price of a gallon of gas changed over 7 years? Well, all we do is we take this 368 minus $2.31, and what is that? $1.37. So it looks like it's gone up $1.37 over those 7 years. But a different question about how this has changed is, what's the average rate of change of these 7 years? And so that's what we're interested in here. So to find the average rate of change of a function, this is closely related to the slope. So this fraction might look familiar to you. That's what we use to find the slope between 2 points. X1, Y1, X2, Y2. So we can use that. And so to find the average rate of change, we can look at it in any of these ways. We divide the output by the input. That's what this one is saying. The second one is delta y over delta x. That's just saying, how is y changing with respect to how x is changing. And then down here we have this average rate of change written with function notation. So this first question says, using the data in table 1, find the average rate of change for gas between 2007 and 2009. So what we're going to look at is 2007 here and 2009. And what we can see is it's decreased. But to find the average, what we're going to do is we're going to do the change of the outputs. Okay, so the change in the outputs, we'll say $2.41 minus $2.84 divided by the years or the inputs. And so the inputs are the years 2009, that corresponds to $2.41 minus 2007. And what we get here is negative 43 cents over 2, which comes out to about 22 cents or negative $0.215. So about 22 cents that it's decreased on average per year. So what this means is, over those 2 years, on average, each year, the price of gas is decreased by about 22 cents. So that's interesting. Let's see how this works if we're given the graph. So here we have a graph of a function. Find the average rate of change on the interval from -1 to 2. So I'm going to zoom in here. So from -1 to 2, -1 is here to 2. So I'm going to look at this point and this point. So if I want to find the average rate of change, one way we can do that is draw this line that connects those 2 points. And if we want to find the average rate of change of that line, it's just the slope. So it's simply the slope of this line. So the coordinates of the first point are -1, 4, and then 2, 1. So if we wanted to find the average rate of change, all we need to do is get the slope. So average rate of change, that's the same thing as saying, what's the slope between those 2 points? And so the slope equation that we saw above is y2 minus y1 over x2 minus x1. So what we're going to do is we'll take the second y value. How about we say x2. Okay, let me back up a little. x2, y2, and then let's label this x1, y1. Okay, so y2 will be 1 minus y2. Y2 is equal to 1. So we'll do 1 minus y1, which is 4, divided by 2 minus -1. So we get -3 over 3. And so this comes out to -1. So that's the average rate of change in that interval. Let me make sure I got that correct. There's a mistake here. This point right here is mislabeled. That should be 2, 2. So sorry about that. So that's a 2 here. So that means y2 is going to be a 2 here. So this will be a -2/3. So that should be our answer. -2/3 is our average rate of change. Sorry about that. Okay, but that's how we find the average rate of change. So again, it's just the slope between those points. That's how we can think of the average rate of change. All right, the next example, compute the average rate of change. Now we're given, on these two examples, we're given an equation for the function, and we want to find the average rate of change. So compute the average rate of change of f of x equals x squared minus 1 over x on the interval 2, 4. Well, I don't know exactly what this graph looks like, but let's just say I have suppose this is the graph of a different function, and let's say this is x1, x2. So that's our interval that we're looking at. So suppose here is x2 and here is x1. So what we'd do is we'd find those corresponding points, and then we find the slope in between, the slope of the line that connects those points. So to find those points, this point here is x sub 1, comma, g of x sub 1. So I input that x value into the function to get the y value. And then this is x sub 2, comma, g of x sub 2. Okay, so that's what I'm going to do here. I'm going to input these x values into the function to get the corresponding y values. So how symbolically, I could say x2 minus x1, that's going to go in the denominator. And then in the numerator, we're going to say f of x sub 2 minus f of x sub 1, and that'll give us the average rate of change. Okay, so when I input x sub 2 into this function, I get 2 squared is 4 minus 1/2. That's 7/2 minus f of x sub 1, which is 2. I did this. I'm trying to go too fast here. X sub 1. So this, let me label this. This is x sub 1. So I did it a little bit backwards here. So 7/2, that's the x sub 1 value. So f of x sub 1, so I'm going to say 7/2 here. So I just did them a little bit backwards. So this is f of 4. 4 squared is 16 minus 1/4. If I get a common denominator of 4, that's 64/4 minus 1/4 is 63/4. So that's this. Divided by x2, which is 4 minus 2. Okay, so to simplify this, the denominator is going to be 2. The numerator, I get a common denominator. I'm going to make this 14/4. So 63 minus 14 is 49/4. 49/4 divided by 2, that's the same as 49/4 times 1/2, which is 49/8. So that would be the average rate of change for this function. Okay, and then the last one, find the average rate of change for the function x squared minus 5x on the interval x, comma, x plus 5. Okay, so this is a little bit more abstract. Let's say the function, so what do we have? We have a parabola. If I factor this, so I'm going to pass through 5 and 0. So my graph is going to look something like this, let's say. All right, and now we don't have actual x values. We have this written algebraically, or in symbolic form. So x and x plus h. So what I'm going to say is, well, let's say that this is x, and then this value, let's say, is x plus h. And what that means is the distance between these is h, right? So I start at this first x value. then I move h units to the right to get the second x value. So to find these points, just going to plug those points into the function, just like we did up here. Okay, so this will be a little bit more complicated, but we can do it. So f of x plus h minus f of x divided by x plus h minus x. All right, so f of x plus h, so what that means is I'm going to input x plus h into this function wherever we see x. So x plus h squared minus 5 times x plus h minus, now I'm just putting x into the function, which is x squared minus 5x. And then in the denominator, those x's are going to cancel, so I'm just left with h. Okay, and so what we can do is we can simplify this. Multiplying x plus h squared, multiplying that out, you need to multiply those two binomials together. So x plus h times x plus h. So we get x squared plus xh plus xh, so plus 2xh plus h squared. Distribute here, I get minus 5x minus 5h. And then distribute here, I get minus x squared plus 5x. All divided by h. And then a bunch of stuff is going to cancel. The x squareds cancel. The 5x and negative 5x cancel. And then I can factor out, well, I get 2xh plus h squared minus 5h divided by h. And what we see is I have an h in each term in the numerator. So I'm left with 2x plus h minus 5 divided by h, and those h's can cancel. So what I'm left with is, I'll just highlight it here, 2x plus h minus 5 is the average rate of change. Now this isn't a numeric value because I still have an x and an h in it. But what this is saying is if I pick an x value and then I pick some h value, for this function I could get the average rate of change. So what this really is this is a formula for the rate of change for this particular function. So whereas the previous example, I was given two exact values I wanted to find the rate of change between. Now, I don't have those values, but what I could do is if I said, well, let's say I want to find the average rate of change between 2 and, let's say, 4. If I did that, my x value would be 2. My h value is the distance in between those. That's also 2. And so if I plug those into this formula down here, I would get 2 times 2 is 4, plus 2 is 6, minus 1 is minus 5 is 1. So I would get an average rate of change of 1. And so what this is telling us is I have a formula that I can find the average rate of change based on any value. So this one is a little bit different, but we'll see this when we do the difference quotient